chapter 11 that we're in right now, Kara, we put that away? The rest of chapter 11 that we're in right now deals with factoring, okay? And factoring means to break a number down into its factors. So when you make a factor tree, you are factoring a number. Like, for example, I'm just going to do a real easy one. If I take 6 and I make a factor tree for it, it would be 2 times 3. So I just factored 6, because instead of calling it 6 now, I'm calling it 2 times 3. So that's what factoring means, is to break it down into its factors. Okay? The first type of factoring we're going to do, because there's a lot of different ways you can factor, is factoring with the greatest common factor. So the top half of this sheet is really just it's the same as what you were just doing on that maze worksheet. So we're not looking at the top of this sheet. We're going to look at some of the examples down here on the bottom, okay, where it says greatest common monomial factor. Really what we are doing here is like the reverse of the distributive property. Okay, so we're going to take the common factor out. That part you already know how to do, and then we have to figure out what's left. So let's take this first one. This first one's real easy. If I have 6x and 3, what would be the GCF of those two things? Just 3, right? No x's, because I can't take an x out of the 3. So my GCF is 3. Now, if I take the 3 out of the 6, and when I say take it out, really I'm saying divide. When I take the 3 out of the 6x, what do I have left?
I don't think
2x.
I got paper.
This is in your notes packet. Okay? So 6x divided by 3 is 2x. Okay? And then if I take 3 out of 3, what would I be left with?
You'd be left with 1.
You're dividing, yep, so it would be 1. Okay? And that's what this would look like factored. See how that now looks like a distributive property problem?
Yeah.
Like I would take the 3 and I would multiply it back through and it would turn back into that. So it's like you're undistributing. You're doing the backwards of the distributive property. Okay? Let's try...
I don't know where my notepad is.
Okay, there's some more on the front table there. Let's try number 9. Let's head over to number 9.
Yeah.
So I've got these 3 terms, 3n to the third, 12n squared, and 30n. Okay? 3, 12, and 30. What's the biggest thing that goes into those?
3.
3. And how many n's could I possibly take?
You could probably take like 3. No, 1.
Okay. Why can't I take 3? Right, because you've only got 1 to take here. Okay? It would be like Roxana has $3 in her pocket, Gearson has $2 in his pocket, and Cassidy has $1 in her pocket. And I want to charge them all the same amount of money. The most I could charge them would be $1 because that's all Cassidy has to give, right? So, not Cassidy. I could, but that wouldn't be fair to Roxana, right? Because she'd be paying 3 and Cassidy would only be paying 1. So if I want to charge everyone the same amount, I kind of have to go to that lowest amount, and that's the amount that I can take. So I can take 1n. Now, if I take 3 out of 3, what did we say I'd be left with? Isaac, why don't you just grab yourself another
I
note?
know, but it's in here somewhere.
Okay, because you're missing out on all these examples. I would have 1. If I take an n out of n cubed, what would I be left with? N squared, I would have 2 n's left. Devin, you with me over there? Okay. Yep.
I don't know how you get the 3n.
Okay, so I started by asking myself, what's the GCF of 3, 12, and 30? The biggest thing that goes into all 3 of them is 3.
Okay.
And then the n came from, I looked at all the n's. This one has 3, this one has 2, this one has 1. The most I can take then is 1.
So the greatest common factor always goes on the outside?
Right, so you put the GCF on the outside, and then what's left over goes on the inside. Okay? All right, if I take 3 out of 12, what would I be left with? 4. And how many n's would I have left? 1, because it used to be n squared and I took out an n. And then if I took 3 out of 30, I would be left with 10. And notice my symbols here, the minuses came from there. All right, I kept my symbols exactly the same.
Why you ain't got no N on the 10? Because you're...
Why don't I have an n on the 10? Hunter? Right, I'm taking an n off of everything. This one only had 1, so now it has none left. Okay. This is a 10. This. Guys, can you stop talking? This here is a 1. Now, could you get away without writing that 1 in there? Yes. But I kind of do out of habit so that you can see 3 times 1 would give you 3. 3 times 4 would give you 12, and 3 times 10 would give you 30. N times n squared gives you n cubed, n times n gives you n squared, and n times nothing would give you n. Okay? Let's do one more. Let's do number 7. Take a look at number 7.
That's the very back of the folder.
Okay.
Everything fell out.
Yeah, we can do 14. So let's start with the 18, the 12, and the 24. Biggest thing that goes into all of them. 6. Okay? If you wanted to do factor trees for all 3, you could. Okay?
We're on 14 here.
Jumping over to 14. I know, but then I had a request to do 14, so I'm doing 14 now. Okay? Y'all with me? All right.
14.
Now let's look at the letters separately. The M's first. How many M's could I take from everything? I can take 2 though, right? Because they all have 2. I'm trying to take the largest amount that I can. Okay, so I can take both. Yep, because they all have 2 to give. How many N's could I get away with taking? 2, right? Because this has 4, this has 3, this has 2, so the most I can take is 2. Oh, I'm going to rewrite
Why
this down
can't
here.
you take 4 or 3?
Can I take 4 from this one? Or this one?
But you can't take 2 from 3.
I can, and I would have 1 left over. Okay, so the amount that you're taking, you've got to take the same amount from all of them. So really it's your lowest number that you're going to end up taking. I'm going to rewrite this down here. So this is 6m squared n squared. Now I'm going to figure out what's left. 6 times what makes 18? 3. And then I took 2m's, so do I have any m's left?
No.
And I took 2n's, so I would have 2n's left. So this is what I'm taking from everything. Minus 6 times what would give me that 12? 2. I took 2m's, so do I have any m's? And I took 2n's. 1 n left, yep. And then 6 times what would give me 24? 4. Do I have any m's left? And do I have any n's left? No. There's my final answer. Okay? That's factoring. Does that make sense? That's factoring with GCF. There's a lot of different ways to factor. Guys, can you stop the conversation? You're going to have time to talk in a minute. Okay? Okay? Questions on this at all? Okay, the one thing that, if you look up at the top, see it says factor and then write prime if prime. Prime means that there's nothing you can take from everything. Okay? Do you see any on here that might be prime? Somewhere where you can't take the same thing from all of them?
3.
You could take 6 from each of those.
11.
11. Okay, 11 you couldn't take anything from the 2, 3, and the 5. But you could take some X's, right?
Oh. 10.
10. Because you can't take anything from 9, 4, and 12. They don't have anything in common. And this one has an M, this one has an N, and this one doesn't have anything at all. So this one here is prime. Okay, because there's nothing I can take from it. Okay? Homework tonight is to finish just the bottom half of this page. So the ones that we did not do together, the rest of those are homework for you. The GCF maze that you did, that needs to be turned in by the end of class. So if you are done now, they can go in the top tray. If you are not done, finish that first. Otherwise, you can work on your homework for the rest of the hour. And I'll hand back tests.